Part C, we already have the e and the natural log right next to one another, so those would cancel right away, leaving us with x cubed on the left-hand side and 8 on the right-hand side. Now think back to whenever we had x squared equaled some number. To undo a square, we would take the square root of each side, putting a plus or minus out front because we were undoing an even power. Here, if I wanted to undo an odd power, instead of taking the square root of each side, I need to take the cubed root of each side. So that would leave me with x equals the cube root of 8. I don't have to put a plus or minus because this is an odd power. This is sort of like an introduction to something you're going to be seeing later on in Algebra 2 after Christmas break. But you essentially need to ask yourself, what cubed would give me 8? And the answer is 2. I'm also going to show you how to plug it into your calculator real quick. Again, because we're going to come back to this later. So we would put a 3 and then hit second and the little power button right here. So that shows me it is the cube root of 8. Notice how I get 2. Example 4 shows us when we use the natural base in real life, and the most common example is when something is compounded continuously, and that would be like interest. So let's say we were looking at this equation right here. I just want to go over what each part represents. A would be the total or the final amount. P stands for principal, or your initial amount, the amount that you start with. Oops, sorry, I didn't realize you can see that. E is the natural base, so remember E is just a number. R stands for rate. Now your rate, if I give it to you as a percentage, needs to be rewritten as a decimal, meaning you take the decimal place and move it left 2 units. T stands for time. Now, if I were looking at something like Part A, it says you deposit $1,000 in an account that pays 8% annual interest compounded continuously. What is the balance after 1 year? The first thing that we need to do is use the information given in the problem to write an equation. Now, because it said compounded continuously, I know that I need to use A equals P times E raised to the RT power. Now, in this equation, I know that $1,000 was deposited. So P is 1,000. The interest rate is 8%. Now, if it's 8%, remember we need to take the decimal place, which is currently right here, and move it left 2 units. So 8% is equivalent to 0.08. Let's plug this into our equation. 1,000, E rate was 0.08, and then T is time. So if I'm just writing a general equation, I would just put T here, but I do want to know what is the balance after 1 year. Year is a measurement of time, so I'm just going to put a 1 here. Let's plug it into our calculator. 100 times E to the 0.08 times 1. I'm going to close that parenthesis there. Now we're going to have to do some rounding because this is an approximation. It's usually up to you how far you would like to go, but because we're dealing with money, we should be rounding 2 decimal places because we're dealing with dollars and cents here. So I would write my final answer as approximately $108.33 because there's an 8 after the 2, meaning we need to round it up. So approximately 108.33. All right, part B. You deposited $1,500 in an account that pays 7.5 annual interest compounded continuously. What is the balance after 1 year? So again, we're going to use the A equals PRT model. I want to know the final amount. We've deposited $1,500. E stays the same because this is a natural base. The rate, we had 7.5%. We need to take the decimal and move it left 2 units. So this would be 0.075 times after 1 year. So 1 year is measurement of time. Let's plug that into our calculator. So it was 1,500 times E to the 0.075 times 1. Remember, because we're using dollars and cents, we should go 2 decimal places. So it's 0.826. That 6 means we should put 0.83. So it's $1,616.83. All right, part C, and then we're done. What is the total amount for an investment of $1,000 invested at 5% for 10 years compounded continuously? Why don't you pause the video, try that real quick, and then we'll check our answers. So there's my final answer. You can see my setup and the amount. If you didn't get that number, let's just make sure you plugged it in correctly. We had 1,000 E to the 0.05. Now this 0.05 has to be multiplied by 10. And then I close my parentheses. See how I got that number? If you would have plugged it in like this, so the 0.05 and then another set of parentheses times 10, what you would have done is you would have multiplied it by 10 after it'd taken the E of the 0.05. So you really need to make sure that the 0.05 is being multiplied by the 10 inside of the power, inside of that parentheses. Last thing I want to talk about, because all of these were word problems and we were dealing with dollars and cents, we need to make sure we include our units.